Picture this. You've just walked out of your Cambridge IGCSE Physics 0625 exam. You sit down, you're feeling confident, right? You think you totally nailed that tricky calculation on density and flawlessly explained resultant force. But then, fast forward to results day, and your grade boundary completely slips. Why? Well, because you didn't answer the way the syllabus actually demands.
And then this brutal reality stares right back at you. 0 out of 4 marks. The examiner's red pen has completely struck down an answer you were fully confident in. And it's not because you didn't understand the physics. You knew the formulas. You knew the concepts. But you lost everything because you didn't know how to structure your response for the specific rigors of the 0625 mark scheme.
So here is my zero fluff promise to you for this explainer. Today, we are completely eliminating those painful mistakes. We're mastering the high-mark exam strategy specifically for mass, weight, density, pressure, and resultant force. No generic study tips, no time-wasting fluff. Just pure, mark scheme-aligned tactics that are going to instantly elevate your answers.
All right, Section 1, the examiner's red pen. Let's look at exactly why you lose marks.
Let's literally look over the examiner's shoulder for a second and uncover why hardworking students are just bleeding marks on their physics papers. We need to dive into this list of the most common painful mistakes that ordinary revision simply won't fix. The examiner is actively looking to dock marks if you forget units in your final calculations. If you calculate pressure, you better have pascals or newtons per square meter written down. They will also aggressively penalize you for rounding numbers too early. If you round your area measurement before calculating pressure, your final answer is going to fall entirely outside the acceptable tolerance range. And vague scientific explanations, things like the force pushes it to make it go faster, that's an instant 0. You need to talk about resultant force causing acceleration. The exact same goes for graph axis scaling errors when you're plotting weight against mass or giving weak practical improvements, like do it more carefully, instead of saying use a digital balance to reduce reading uncertainty.
Now, the Cambridge syllabus specifically sets these traps in the forces in motion and forces in pressure chapters. This is the precise territory where examiners test your rigorous handling of measurements, units, and data tables. Whether we're talking about Section 1.4 on volume and density or 3.5 on pressure, this isn't just about memorizing formulas anymore. It's about executing them flawlessly in these specific syllabus zones.
Now, I know you want the quick fix to stop losing these marks. And in a moment, I am going to show you the exact examiner clue that changes your answer completely. But first, you absolutely need the framework that makes that clue obvious. Because without this underlying structure, you'll just keep making the exact same errors when the exam pressure hits.
Moving right into Section 2, the Data Coach Framework. This is your 4-part answer fix.
So to fix all of this, we need a structural solution. The crucial point here is applying this exact 4-step framework to every single calculation, explanation, or practical question you face. Step 1, state the concept or equation explicitly. Don't just keep it in your head, literally write it down. Step 2, pull the evidence or data directly from the question prompt and substitute it in. Step 3, apply your scientific reasoning. Show that mathematical step or the logical link. And Step 4, lock it all in with examiner wording. Use the exact physics terminology they expect, like resultant force instead of overall push.
Okay, Section 3, spot the fatal error. Let's look at some practical mistakes.
Let's test this new mindset out right now. I'm going to challenge you directly with a typical Cambridge-style practical investigation scenario. Check out this typical data set. We've got a mass of block at 450, volume of block at 150, calculated density at 3, and a resultant force at 10 Newton. I want you to just pause for a second and ask yourself, what would the examiner's red pen instantly cross out here? If you submitted this exact table in your Paper 6 practical, where are the critical failures? Boom, the examiner strikes immediately. And here is exactly why. The table is a complete disaster of missing units. You have a naked number 450 for mass, like, is that grams or kilograms? Volume is missing cubic centimeters. Density is missing grams per cubic centimeter. Literally, the only correct entry is the 10 Newton for resultant force. Plus, there is a total lack of uncertainty checks or repeat readings to spot any anomalies. This is exactly how top students drop a whole grade boundary on practical questions. Section 4. Perfecting the exam answer and securing full marks. Let's see how this builds into an actual exam answer comparison so you can perfect your own response. Notice the massive difference here. The flawed answer says, density is 3 because 450 divided by 150 is 3. The force pushes it. It's totally vague and has 0 units.
Now, look at the top band answer. It actively uses our framework. It states the concept, explicitly writing the equation, density equals mass divided by volume. It plugs in the evidence, 450 grams divided by 150 cubic centimeters. It gives the final answer with correct significant figures in units, 3.0 grams per cubic centimeter. And finally, it uses exam-safe wording. The resultant force of 10 newtons causes acceleration, replacing that childish phrase, pushes it. That right there is how you secure full marks. Before you ever even consider turning in your paper, you absolutely must run your practical and calculation answers through this exact final answer checklist to guarantee your reliability and accuracy. Ask yourself, are units included on every single final value? Are your significant figures consistent with the raw data provided? If you plotted weight against mass, does your graph scale actually take up more than half the grid? Have you identified any anomalies in your density measurements? And is your final conclusion strictly supported by the data you wrote down?
Which brings us to Section 5, your next mandatory step, dealing with timing and pressure. So you now possess the framework and the checklist, but we have to reveal that crucial clue we teased earlier and explain why our job is far from over. That missing clue I mentioned? It is always hidden in the command word itself. Words like describe, explain, calculate, and evaluate dictate entirely different response structures. But here is the really stark reality. Knowing the data coach framework and identifying the command words is completely useless if you run out of time on the exam. Timing and intense pressure will completely shatter your strategy if you haven't mastered pacing. So we now face a brand new, unresolved problem. To solve this terrifying timing crisis, you desperately need a red pen rescue route. Ask yourself, if the exam was tomorrow, would your current pacing actually allow you to execute the data coach framework? Or would the ticking clock force you right back into those zero-mark habits? Think about that for a second. To lock down your final preparation, you need to click the next explainer on screen right now for the Physics 0625 Last 7 Days Revision Map, where we tackle timed answer writing systems. And remember, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Do not let time rob you of your hard-earned marks. Click the explainer on screen right now, and I'll see you over there.